In this module, we'll turn your mental model into a shareable blueprint. Using the eIDAS banking scenario, you'll see what to document, how to structure it, and how to adapt the same architecture for business, technical, and compliance audiences. You've already mapped the full onboarding and e-signature journey. Now we move from understanding to articulation. In this module, you'll turn that solution into clear documents and diagrams that secure funding, satisfy reviewers, and give delivery teams a concrete blueprint to build from. Architecture documentation in eIDAS projects isn't just paperwork. It's the shared language that keeps business, IT, security, compliance, and vendors aligned on the same solution. It enables major decisions, funding approvals, vendor choices, risk acceptance, and sign-off from regulators. It then acts as a compass for design, build, testing, and operations, so teams don't improvise the rules. Finally, it becomes evidence for auditors and supervisors that your eIDAS solution is designed and governed systematically. Think of an architecture document as a story that moves from why to how. You begin with context and scope. What problem we're solving in eIDAS banking and who's involved. Next, you summarize key requirements, describe the main use cases and user journeys, and only after that introduce the logical and integration views. You then address security, compliance, risk, and operational aspects. Throughout, you keep reusing the same end-to-end view, zooming in and out as needed. The context and scope section is where you anchor the whole eIDAS initiative. You spell out the business problem, like enabling remote onboarding and qualified electronic signatures for banking, and you specify which channels, countries, and customer segments you're targeting. You also frame the regulatory landscape, eIDAS, AML, and KYC rules, plus internal policies. Finally, you draw a clear boundary around what's in scope, what's excluded, and which systems or partners you depend on to succeed. This slide gives the big picture of what the architecture must deliver. Functionally, it has to support remote identity proofing with different options, enable creation and use of qualified electronic signatures for contracts, and capture solid evidence and audit trails for every step. Non-functionally, it must be secure, handle high onboarding and signing peaks, remain highly available and resilient, and provide full compliance, traceability, and retention of records. Now we turn those requirements into concrete flows. The architecture must handle. Focus on 4 primary journeys: onboarding a new customer, reviewing a contract, performing a QES signature, and re-signing when terms change. Around those, design supporting paths. Retries for identity proofing, exception and manual reviews, and revoking consent. Each step is mapped to clear actors: the bank front end, the identity provider, the QTSP, and the evidence store working together. Next, we separate concerns into 4 logical building blocks. Digital channels handle user interaction, onboarding flows, and basic customer data. The orchestration layer coordinates identity proofing, talks to external eID providers, and routes decisions. The trust service provider executes qualified signatures and manages certificates. Finally, evidence and audit components capture logs, evidence records, and reports. Together, these clear responsibilities and interfaces make it easier to design for consistent eIDAS compliance. Here, the focus is how every system speaks a compatible language. The bank's digital channels call an integration layer through REST APIs. That layer then talks to identity providers using SAML or OpenID Connect, and to eIDAS services using their dedicated protocols. When a remote signature is triggered, the QTSP receives a signing request, authenticates the user, returns signature data, and sends status callbacks. In parallel, evidence and logs stream into internal repositories for audit and reporting. At this point, we shift from what the solution does to how we can prove it's trustworthy. Picture 3 layers. First, access control. Strong authentication for every channel and consistent authorization across services. Second, data protection. End-to-end encryption, clear key ownership at the QTSP, and network segregation between trust services, banking cores, and partners. Third, compliance. Mapping Low-A and QES requirements, full audit trails, and alignment with AML, KYC, GDPR, and internal policies. Non-functional requirements answer the question: How well does the solution run in the real world? We define performance expectations, like how many onboardings or signatures we support, and what latency still feels snappy for users. We plan for failure with redundancy, automated failover, and recovery aligned to QTSP availability. We design for easy change, new ID schemes, new rules, minimal downtime. And we instrument everything, metrics, logs, and alerts that quickly reveal problems. The key idea here is one blueprint, many lenses. Executives care about value, risk, and outcomes, so show them customer journeys, benefits, and a very simple partner landscape. Technical teams need enough detail to actually build and integrate, so use component, sequence, and data flow diagrams that map cleanly to real environments. Compliance and risk stakeholders need to see where controls live and how evidence traces back to specific regulatory requirements. Think of the executive summary as a narrative in 3 moves. First, state what you're building. A remote onboarding flow with eIDAS-compliant identity proofing and qualified e-signatures for bank contracts, plus the core value it delivers. Second, explain how trust is achieved, which QTSP model you chose, how it's integrated, and who owns which responsibilities. Third, highlight the critical decisions, trade-offs, and top risks, paired with concise mitigations, so leaders can judge viability quickly. Treat your architecture documentation as a living blueprint. Start by anchoring everything to a single source of truth. One glossary, one component catalog, one set of master diagrams reused everywhere. Then treat changes like code, version them, and record why decisions changed. Maintain traceability from requirements to components to controls and evidence. And define owners and clear triggers so updates happen whenever regulations, countries, or providers change. You now know how to turn an eIDAS banking solution into a coherent architecture blueprint with consistent views for every stakeholder. You've seen how strong summaries and decision records support governance and regulators. In the next module, we'll extend and future-proof this architecture for new channels, countries, and frameworks.